we're doing the back, example 3 and on from day 6 in Algebra with quadratics. So let's look at a rhombus. A rhombus, we know all four sides are congruent, but if you look at this picture, we're talking about angles. So in a rhombus, we know that the angles, the diagonal bisects the angles. So the word bisect means it cuts it in half, so we're going to set these two things equal to each other. So we'll subtract our x's to one side. It doesn't matter if I subtract 5 over here, and we'll get 3x. If you add 20 this way, you get 21. Divide by 3, you get x equals 7. This one wants us to go a step further. It says find the measure of FED. So FED is over here. So we need to figure out what angle F is in order to figure out what angle E is. So let's plug these numbers in here. So 35 plus 1, this is 36, and 36. So that makes angle F over here 72 degrees. Now you have to remember, these are not congruent. This is an acute angle, this is an obtuse angle. So just like in a parallelogram, consecutive angles are not equal. They are called supplementary. So you're going to take 180 minus 72 to figure out what that angle is. Let's take 180 minus 72. That leaves me the measure of angle FED equals 108. So knowing that these are equal, knowing that consecutive angles add up to 180, that is how I would find that one. Alright, the next one is related to squares. Another thing to remember in a rhombus, I didn't use it on this one, but that the diagonals are perpendicular. Sometimes that helps on your rhombus questions if you're trying to find some angles. Alright, square. We have a square, and we're talking about the length. SW is 2x plus 13, okay, and WU is 8x minus 41. So we got to think about diagonals in a square. In this case, diagonals are congruent, but that doesn't really help us. They're not on the same line, or they're on the same line. We also know diagonals are bisected. If diagonals are bisected, these two things are equal. Subtract, add, and then divide both sides by 6. X equals 9. Okay, let's see now what it wants us to find. Find VT. So now it is important that the diagonals are congruent because this diagonal is the same length as that diagonal. So let's just put it in like SW. SW would be 2 times 9 plus 13. So 18 plus 13 is 31. And remember that that was just half of the diagonal, so the whole diagonal VT, we'd have to double that. So we're going to say it's 62. Okay, so that's squares and their diagonals. Okay, now we have a trapezoid. The thing about trapezoids, you can see the parallel lines. Angles between parallel lines are called consecutive interior angles. So I know that means that they add up to 180. So we're going to do 54, that's not a 4. 54 plus 8x plus 6 equals 180. These are called consecutive interior angles. We learned about those in Unit 1. When you have two parallel lines, the angles between them are consecutive interior. So I have 8x plus 60 combine my like terms. Remember, you can pause the video if I start writing too fast. Or pause the video, see if you can solve it. Okay, then I'm going to divide. So x equals 15. Go back, what does it say? It says solve for x, so I'm done with that question. In an isosceles trapezoid, we know that isosceles means these legs are congruent. It also means these base angles are congruent. Let's say I subtract my 2x. I'm going to add the 12. And divide. So I get x equals 13. Now I need to plug it in to find all these angles. So 2 times 13 is 26. 26 plus 27. 26 and 27 is 53. So that means this is also 53. So the other ones are called consecutive interior angles. So 180 minus 53 equals 127. So that's going to be your other two angles. So that's an isosceles trapezoid, means the two legs are congruent and the base angles are congruent. Alright, let's look at this rhombus. This one's a little bit harder. You'll notice this one has quadratics in it. So it says ABCD is a rhombus. Find the possible lengths for AC. So they give us AE and EC. In a rhombus, diagonals bisect each other. So I know these two things are going to be set equal. When you solve a quadratic, you always want to set it equal to 0, but you want your x squared term to be positive. So on this one, I'm going to minus these to this side so that I get a positive 2x squared. Now I'm going to subtract the 3x to the other side and bring down the minus 5. Now we've got it set equal to 0. We have a positive x squared. Remember, this is like A, B, and C. When you put it in the x method, the top number is your A times your C. That gives me negative 10, and B is your bottom number of negative 3. So you want factors of negative 10 that add up to negative 3. So let's say 2 and 5. 5 would work. 2 and 5. To make a negative 3, I'm going to have a positive 2 and a negative 5. That makes negative 3. That multiplies to negative 10. So you replace the middle numbers with the 2 and the 5. I'm just going to put the equal 0 at the end instead of the beginning, but then you group them. Mine has a 2x in common. This one has a negative 5, so I'll take out a minus 5. You divide a negative and a negative, it makes it become positive. We regroup our answers together, so it's 2x minus 5 and x plus 1. So to solve, we set each parenthesis equal to 0. Most of you guys just change the sign automatically, which is fine. This one, though, you have to add the 5 and then divide by 2. So x would equal 2.5, or 5 halves, 5 and a half, or 5 halves, which is 2 and a half. Alright, so find the possible lengths of AC. AC cannot be a negative number, so we need to plug these in to figure out which one is going to work. So I'm just going to take a calculator. Usually it's the negative one that doesn't work, but we'll try it. 2 times negative 1 squared plus 3 times negative 1 equals negative 1. Okay, so when I plugged in negative 1 for AE, I got a negative number. And when I plugged it in for AC, because these should be equal, they both came out negative, and I can't have a negative length. So the only one that's going to work here is the 2.5. Find the possible lengths of AC. So let's plug in the 2.5. 2 times 2.5 squared plus 3 times 2.5 equals 20. So if each of those is 20, AC would equal 40. What property did I use to figure that out? So the reason I set those equal is because the diagonals are bisected. I guess the diagonals bisect each other. Okay, the reason I put this next one on there without a picture is because if you're not given a picture, you need to be able to how to interpret the information. So it says GEOM. So when you're doing this, you draw a picture. Whatever your corner you want to start on is fine, but if you start with the letter G here, and I go this way, this has to be E, this would have to be O, and this has to be M. You can't like zigzag around your picture. You have to go around the outside in the order that the letters are in. So find the perimeter of the rectangle. Before you can find perimeter, you gotta know how long the sides are. So what do we know is true in this picture? In a rectangle, remember, gotta figure out what kind of shape did they want me to draw. In a rectangle, opposite sides are equal. I think it says congruent, equal, congruent, you probably know what I mean. So if you set these equal, 5x equals 3y plus 2, and the other one would be 2x plus 1 equals y plus 3. You'll notice in this one we have x's and y's. So this is called a systems of equations. You need to get one of the letters by itself in order to solve this. I think these both have numbers. I don't want to divide by a 3 or a 5. But over here, this y doesn't have any numbers with it. So I'm just going to minus this 3 over. So I get 2x minus 2 equals y. The reason I did that is because now I can put this in place of the letter y. This is solving a system, and I'm doing by substitution. And you would distribute to get rid of the parentheses. I'm going to probably move my x's to the left. So I'll subtract 6x over here and get negative 1x. And if you want to combine those two together, minus 6 plus 2 or negative 6 plus 2 is negative 4. So x would equal 4. Remember, in a systems, you want to plug it back in order to, well, you don't even have to in this one. Sometimes I would plug them back in, but I think if I look at this picture, I can probably figure this out now. It says, find the perimeter. So if I just know the x, 5 times 4, this side's going to be 20. So you know this side's 20. Let's see, I have the x, so I can plug it in this side. 2 times 4 is 8, plus 1 is 9. So even though I don't know y, that's got to be 9 too, because the opposite sides are concurrent. Okay? So now perimeter is adding up all those sides. So that's 40 plus 9 is 49, plus 9 more is 58. And if you want, because you're in the habit of going ahead and finding the y, just plug it in. Like 2 times 4 is 8, minus 2, y equals 6. If you want to do that, you may have to. They might have x's and y's on the same side, and you need that. But otherwise, if you can just solve for the 1 and plug it into your picture to find the perimeter, that's fine too.